Okay, to find maximum and minimum values of the function x squared y, subject to the constraint that x squared plus 2y squared equals 6, we need to take a gradient of the constraint function g and also the gradient of the original function f, and at a point of maximum or minimum value, those two vectors are parallel to one another. So the gradient of f is a scalar multiple lambda times the gradient of g. Okay, the gradient of f, taking the partial of f with respect to x, is 2xy, and the partial of f with respect to y is x squared. Taking the gradient of the constraint function g, the partial with respect to x is 2x, and the partial with respect to y is 4y. And writing down the Lagrange equation here, these two vectors are parallel to one another at critical points, so one is a scalar multiple of the other. We call that scalar factor lambda for Lagrange, and it's just a number multiplying the gradient of the constraint function. So this gives us some scalar equations. The first component of the first vector is equal to the first component of the second vector multiplied by the scalar lambda, and that's equation 1. The second equation we get, the two vectors are identical, they're equal, so their second components have to be equal too, and so x squared is equal to lambda times 4y. That gives us our second equation. We have three unknowns here. We need three equations, and our third equation will be our constraint equation, x squared plus 2y squared equals 6. And there's our system of three equations that have to be solved to identify maximum and minimum values of the function.